everyone, in this video we're going to talk about program evaluation and how it's really related to statistics. And in order to do that, we really have to start by thinking about causal relationships. So kind of the approach that I take is that we always start with a dependent variable, what we might call y, or an outcome of interest. And typically with social science and in program evaluation or policy analysis, we're thinking about changing some outcome in society, some perhaps negative outcome that we want to erase, or some positive outcome that we want to increase. So some examples of things we might want to look at from higher education, which is what I'm most familiar with, would be thinking about perhaps attrition rates or dropout rates for programs or for the university. We know that 26% or so of students from their first year in college do not return in their second year of college. So our question might be, how do we take that 26% dropout rate and decrease it or eliminate it? Turn that 26% dropout rate to, let's say, a 20% dropout rate, or perhaps a 15 or 10% dropout rate. The other side of that coin is we could take really positive outcomes, and what we want to do is think about how do we increase them. So a positive outcome might be the number of students that sign up for tutoring or for help for each semester, and then get the help in their classes to succeed. Or we might look at the number of students that are receiving honors or dean's list. So we might think about how do we increase that number. So once again, we always kind of start by thinking, what is our outcome of interest, our dependent variable, or y, that we would want to change. The other side of that then is the independent variable, or what we might call the x variable, which is the causal force behind y. So there are two ways to think about the x variable. One is to say, well, what are the factors that are contributing to this dependent variable or y outcome? From a strictly program evaluation standpoint, we might say, is the program X having an effect on the outcome Y? So once again, looking at our sort of example with higher education, perhaps we have a 26% average dropout rate from first year to second year. We might say, well, what are the factors that contribute to this dropout rate from year to year? And we might look at some X variables that might be median household income, it might be college GPA, or high school GPA even. It could be a whole host of factors that we can consider on the X side. If we're looking at a program evaluation standpoint, let's say we want to increase the number of students that are getting help with tutoring, maybe we institute a policy change that requires early grade reporting. And we'd want to evaluate, does early grade reporting really contribute to an increase in the number of students seeking tutors each semester to do better in their classes, under the presumption that students would have to know that they're doing poorly before they would actually go get a tutor for help in a course. So once again, we can kind of think about sketching this out as a causal model with a causal chain of events. Once again, on the far right side, we will put the dependent variable, whatever we identify that as. We might identify then several independent or causal variables influencing that outcome. Once again, if we're doing strict program evaluation, we might include our program option as one of those variables that is influencing that outcome. Now, once again, as you'll kind of see in any sketch, the causal chains can become quite complex. And that's not necessarily a bad thing, because what we want to do is use theory, kind of our logic and arguments, to parse out which effect we think is going to have the biggest impact on that dependent variable of y. So once again, sort of thinking about causal chains and causal events are really an important part of looking at program evaluation and sort of the use of statistics in program evaluation and in figuring out solutions to increase outcomes, positive outcomes, or figure out solutions to decrease negative outcomes. Okay, so let's take a look here at how we might think about causal modeling. Generally what we're going to do is we're going to draw some directional arrows in how we think variables link together. So kind of our basic setup here is we have on the right side a dependent variable, which we might simply call y to start out as, and this is the outcome variable that we talked about earlier in the video. On the left side, we have a lot of space for independent variables, and independent variables can be put together in a number of different ways. So I have kind of a dashed line that you can see here that is going to really distinguish between what we call proximate causal variables. Those are the variables that are going to happen directly before the dependent variable. That'll be on the right side of the dashed line. And we have on the left side what we call sort of remote causal variables, or variables that are a little bit more distant from the dependent variable. So kind of what you can see here is that if we have a y variable on the dependent variable side, we might have an x variable that is a proximate cause on the independent variable side. So we have x causes y. We could also have additional proximate causal variables like z and w that also cause y to happen. It's possible then that we have a remote cause k that is a proximate cause of x and a proximate cause of w. In this case, k doesn't exert an independent effect on y, but its effects would be felt through x and w. In this instance, we would call x and w intervening variables. Once again, they kind of intervene between the effect of k on y. So let's take an example here of a couple real variables to try to solidify these concepts of proximate causal relationships and remote causes. So let's say that we are in higher education and that one of our outcomes we're studying is the student dropout rate. We might theorize, perhaps hypothesize that academic performance is a proximate causal force on student dropouts. That is, students who don't perform well academically aren't going to be successful and be able to return to college. We might also hypothesize or theorize that financial problems, perhaps they're simply family financial issues or financial aid issues, also leads to students leaving the university. We also know that under modern financial aid standards, academic performance influences financial issues because if students don't perform academically, making satisfactory academic progress or maintaining a GPA are going to have more financial aid problems. We might then think that as a policy solution or program solution is to have a tutoring program. And this might in turn be a remote cause of the student dropout rate because the effect of tutoring is primarily going to go through academic performance. That is, if we get students involved in tutoring, they're going to boost their academic performance, which in turn should decrease the student dropout rate. So as you can see kind of in the picture, we might think that the tutoring program is a proximate cause of academic performance, but perhaps very much a remote cause of student dropout, where that effect would be a little bit harder to identify, a little bit harder to find. So the real idea behind causal modeling is to give you a sense of where to look for your statistical effects. So if we're doing an analysis of data, we might expect to find the biggest statistical effects being where I'm highlighting the yellow arrows. That is, we might expect to find statistical effects between academic performance and financial problems, academic performance and student dropout, financial problems and student dropout, and the tutoring program and academic performance. We may hypothesize that a tutoring program is an indirect or remote cause of the student dropout rate, but it may be harder to find a statistical effect between the tutoring program and the dropout rate. And similarly, we might think that it may be harder to identify a statistical effect between the tutoring program and financial problems. So drawing out a schematic or a causal model diagram is really helpful to identify what types of variable relationships we should be looking for in our statistical analysis.